So today we'll start with the operations on sets. So in a previous class, as I said that operations on the sets, we have a three, that is union of a sets, intersection of a sets, and a difference of a sets. Okay, we'll just discuss on those three operations. The first one, I'll just take it. Union of a sets. To define this one, I need to consider two sets. That is, I'll take A and B, any two sets. Then the union of A and B is, then union of A and B is the set. Again, it is a set which consists of all the elements of A and all the elements of B. The common elements being taken only once. Okay, as I said that while writing a set, I'll consider it two sets. In both the set, there will be a two or three elements are a common in both the set. In that case, while writing the union of a set, you should mention a few elements which are like a repeated. Those elements you need to take it as only a once. Okay, so union of a set is nothing but what? I'll consider two sets A and B. Then the union of A and B is a set which consists of all the elements of A and all the elements of a B, but the common elements being taken only once. So the symbol we used for a union is this one. You can take it this. This is what the symbol, we'll just use it for a union. Okay, symbolically. So we can write A union B is nothing but A union B. So we can read it this as A union B. So I'll just go with the one example. So to make you understand of this concept is, let A is 2, 4, 6, 8 and B is 6, 8, 10, 12. So find A union B as nothing but A union B is A is 2, 4, 6, 8 union B is 6, 8, 10, 12. A union B is again a set and it consists of all the elements of A and a B, but the common elements being taken only once is nothing but 2, 4, 6, 8. These four are elements of A, and in a B elements, so I will not write it 6 and 8 because these two elements which are already there in A, so I will not repeat those two elements. I will just write it only a 10 and 12. So this is what A union B. A union B is the elements of a and also elements of a B. But while writing the elements of A and B, if some elements are repeated, you just consider those elements only once. Okay, this is what union of a sets. Hope you guys understood this. Okay. So I'll just take it one more example. That is, let A is a ols, A, E, I, O, U, and B is A, I, U. Okay. Now show that A union B is A itself. Okay. A union B. A union B is. A is A, E, I, O, U, whereas the B is A, I, U. Now, together we need to write the set A elements and set B elements, where the elements of A or B are common. Then we'll write it those elements only once. It's nothing bad. I'll just write the elements of A first. A, E, I, O, U. But if you consider the B set, A, I, U, these three elements which are already there in A, therefore I'll not write it those elements. Okay, so A is this one, B is A, I, U, which are already there in this A. So I'll just write it only A set itself. Hence we can write this as A union B is set A itself, and is the proof. Is it clear? Hope you guys understood this. Okay, union of a set. So I'll just go with intersection now. Intersection of our sets. So now for an intersection, again for this also we need to consider two sets, that is let A and B be any sets, then intersection of sets A and B is the set. Again the intersection is also a set of all the elements which are common to both A and B. Okay, intersection is nothing but I'll consider two sets A and B, and intersection will be, again it is a set, and the elements which are like in a and a B, if the elements are a common, the same elements, only those elements we are going to write in a set, and such a set is nothing but intersection of a sets. Okay, the symbol we will use for the intersection is, that is ulta U. Union is what? It is a U. A reverse of that one is nothing but ulta of this union symbol is nothing but intersection. Is it clear? And here is symbolically we can write it this as A intersection B, and also we can write this A intersection B as elements of this set, where that element is also belongs to A as well as that element belongs to B. Okay, this is what intersection of a sets. So we'll just go with the example, that is, I'll just go with the same example for a union what we did, that example only I'll consider. Let A is a 2, 4, 6, 8 and B is a 6, 8, 10, 12. Okay, find A intersection B. Okay, now A intersection B is 2, 4, 6, 8 intersection 6, 8, 10, 12. While writing intersection, you need to concentrate on the elements of a set A and a set B. In these two sets, if the elements are the same, that is the common elements in both the set, only those elements we need to write it in the intersection. 2 which is not there, 4 which is not there, 6 is there, again 8 is there, 6 is there in both the set A and B, only those two elements we need to write. And you can check with the B also, that is 10 which is not there in A, 12 which is not there in A, therefore in both the set only a 6 and 8 is there, Hence A intersection B is 6, 8. Okay, next I'll just go with one more. Let A is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whereas B is 2, 3, 5, 7. Find A intersection B and hence show that A intersection B is a B set. Okay, so now first we'll go with the intersection of these two sets. A intersection B is A is 1 to 10. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then intersection of 2, 3, 5, 7. You just write the intersection. Intersection is nothing but the common elements in both the set. 1 which is not there, 2 is there in this, then 3 is there in this, 4 is not there, 5 is there in the set also, 6 is not there, 7 is there, 8 is not there, 9 is not there, 10 is not there. So how many elements are common in both the set? That is a 2, 3, 5, 7. 2, 3, 5, 7. Therefore 2, 3, 5, 7. This is the set for intersection of these two sets. Now if you look up with the given thing 2, 3, 5, 7 which belongs to a set B, hence I'll just write it this as A intersection B is a B set and also it is a proved. Okay, hope you guys understood this. Next is, I'll just go with the difference. Okay, difference of sets. Now the difference of a set is, the definition is the difference of the sets A and B in this order, that is, it is a set of elements which belongs to A but not to B. Okay, symbolically we can write that is A minus B. This is what the difference of a set. A minus B, we can read it A minus B. That means it is a set and which contains the elements of set A and these elements which are not there in B, then we can call it this is a difference of a set. Okay, so we'll just go with the example, then you will come to know what exactly this. So A is 1, 2, 3, 4, 5, 6. B is 2, 4, 6, 8. Find the difference of A and B and also B and A. A minus B is nothing but 1, 2, 3, 4, 5, 6 minus 2, 4, 6, 8. The elements of A which are not there in B, and that is called as the difference. Elements of A which are not there in B. So 1 is not there in this, 2 is there, 3 is not there, 4 is there, 5 is not there, 6 is there. So elements of A which are not there in this, that is called the difference of A and a B, and those elements are 1, 3, 5. This is what A minus B. Okay, if you get confused with that, So if the elements which are not there in this one, you just slash out. So once you slash these elements, the remaining elements you just write it. Then this will be easy. Okay, we'll do it the same way in the next, that is, and b minus a is nothing but 2, 4, 6, 8 minus 1, 2, 3, 4, 5, 6. Elements of b which is not there in a is nothing but a is there. Okay, so which element is there, you just slash out. A is there, then 4 is also there, 6 is also there, 8 is not there. Elements of b which are not there in this, and that element is like a difference of b and a. Therefore here it is only 8. Understood, guys? Elements of b which are not there in this, and that is what 8. 2, 4, 6 are there in this b set, means a set. Therefore you should not write those elements, only the element of a b which is not there in a, and that element is the required for the difference of b and a. Is it clear? So now I'll just go with the one note. Note is the sets a minus b, a intersection b, and b minus a are mutually disjoint. Mutually disjoint sets. The intersection of any of these two sets is a null set. Okay, is nothing but, hope you guys don't know about this disjoint. So disjoint is nothing but intersection of those elements, you will get it as a null. For example for a disjoint set. For this I'll take example, a is a 1, 2, 3 and b is a 4, 5, 6. I can say that a and b are disjoint set, is nothing but the intersection of a and a b. 1, 2, 3 intersection 4, 5, 6, and there is no common elements in these two sets, hence it is a null, and we can say that this a and b are disjoint set. Okay, now there is a note that the difference of two sets, intersection of two sets, and again the difference of those two sets itself are mutually disjoint, is nothing but symbolically we can write a minus b intersection of a intersection b, and intersection of b minus a is a null. This is mutually disjoint set. Okay, this is what a note you can consider it. Okay, hope you guys understood the operations on the set, that is the union, intersection and the difference of a sets. Okay, we'll just do the exercise problems in the next class, and there is some properties on the union and the intersection is there. Even I'll explain those properties in the next class. Is it clear? Thank you guys.